This is the Audio Precision APX555 B-Series audio analyzer. It is an amazing audio analyzer. It slices, it dices, it stores easily under the bed, and it can be yours for one low payment of only $40,000. Hi, I am Tom Christensen of Neurochrome, and I am here to tell you about some lower cost alternatives to this amazing audio analyzer. And here are some of the alternatives. We have the QA403 by QuantAsylum, we have a pair of external sound cards by Focusrite, and the QA403 is $600, so that is about a 40 dB drop in price from the APX555. The question is, does that also mean a 40 dB drop in performance? This is the QA403 by QuantAsylum. QuantAsylum got started in 2012 out of Snoqualmie, Washington, and they sell these for $600, which is an incredibly low price, especially considering the performance of this thing. And that also explains why they have now moved to Parker, Colorado, probably for some larger facilities, and also it explains why they're having a lot of trouble keeping these products in stock. The chassis is, pretty sturdy. I think it's made of aluminum. It's not magnetic anyway. It's nicely powder coated. There's some digital print on the top. And on the front panel, we find two balanced outputs, two balanced inputs, and they're brought out on these B and C connectors. We also find behind this plastic plug a multi-pin connector, and that is an I2S output. So that allows you to connect directly to the serial input of a ADC, DAC, DSP, and so on. And just for reference, that connector right there would be a $7,000 option on the AP. On the back side of this instrument, we find a USB Type B, so that's not very exciting, but that's how you connect to a PC with this thing. The USB input is isolated from the analyzer part of the instrument, and that's actually a really cool feature. So kudos to QuantAsylum for putting that in. This box draws about an amp from the USB port, so you need a PC with a fairly beefy USB port. You can also get a USB Type B splitter that splits the power and the data and then power it with a battery bank if that suits your fancy. But I find that if I plug this into a USB-C port or a high power USB Type A, it works just fine. This is the Focusrite Scarlett 2i2 4th generation. So that's the current generation, and it retails for about $200, although you can sometimes find it on sale for less. It, as the name indicates, has two inputs and two outputs, and the inputs have two modes. One is a line level input with this TRS jack on the front that also supports an instrument, or you can connect a microphone to each input with these XLR jacks. One thing to be aware of with the inputs of this is that there are some special modes here. One of them is called air. So air adds a little bit of a high frequency hump on the frequency response. So if you're doing audio measurements, you want to make sure that's turned off. Also, the input gain is controlled by these encoders, so it's controlled digitally. And there's a nifty little ring around each of these knobs here, and that lights up about 2/3 of the way in green when your input level is high enough. It turns yellow when it's approaching clipping, and it turns solid red when you're having hard clipping. So that's actually pretty handy. That's kind of nice. The large knob here controls the output level, and the smaller knob controls the level for the headphone output. And on the back side, we find the two outputs. One, they're both balanced in left and right channel. And then we have a USB input and a USB power input. And the latter can actually be pretty handy because I imagine this draws quite a bit of current from the USB output. So if you are running on a laptop that's not plugged in, for example, you can plug this directly into a battery bank. So that's pretty cool. The chassis is solid aluminum, or not solid, it's an extruded shape, of course, but I mean, it's probably, I would say, 3 millimeters thick, so it's pretty sturdy, and it's certainly a bit heavier than the QA403, although, I mean, it's not exactly heavy. So it seems like a quality product. Let's see how it performs. And finally, the Focusrite Scarlett Solo 3rd generation. I've had this for a few years now, and I actually use it for to power my headphones for Skype calls and stuff like that. And it's a pretty nice and very basic audio interface. As the name indicates with solo, it has only one input, and that can be used either with the XLR jack or with the TRS jack. There's a separate gain for XLR microphone input and TRS line level. And it's just a potentiometer, nothing fancy. There's this plastic ring around it that emulates a VU meter, so that lights up green when the level is okay, yellow when it's approaching clipping, and red when it's hard clipping. And that actually is pretty handy for audio measurements, as I'll cover in a bit. The output, both of the headphone jack and of the left and right channel output on the back, is controlled by this large knob, which controls a potentiometer. And on the back, we also find a USB input and one of those Kensington lock slots, so that's not very exciting. What is exciting about this is the price. Focusrite currently has these refurbished for $80. And so I would imagine that you can find these for even less on the used market. And for $80, you get an enormous amount of value. The current generation, the 4th generation of this, sets you back about $150. First, let's have a look at the performance of the APX555, including the control software that it comes with. Because let's face it, the hardware doesn't have any knobs and buttons that you can push, so you have to rely on the software. And that's the case for all the analyzers in this video. So it's important that the software works well. And I'll be the first to admit that I have pretty high standards and I'm not very patient when it comes to software. So if I grumble a little bit too much, bear with me. I mean, you can look at what I grumble about and make up your own decisions about, well, will this bother me and how much and so on. And what I present here is really just my opinion. I'd like to think that I have at least an informed opinion on these matters. After all, I mean, in addition to my engineering degrees, I went back to school for a degree in psychology, and part of my studies there was on human factors engineering, so how humans and machines, including software, work well together. So I do believe that I have a pretty decent educational background on this. I'm not an expert, I haven't done this for 20 years every day, but at least I think I have an informed opinion. But hey, with that disclaimer out of the way, let's dive into the software. As we can see, it is organized in basically 3 different sections. The first section here is the signal path setup. So that's where we set up which type of input we want to use, how many channels, similar for the output, and so on. That is also where we set the sampling rate. So I want to measure with a 20 kilohertz measurement bandwidth. So that automatically chooses the 44.1 kilohertz DAC in the APX555. As we can see here, the noise dropped from about 1.8 microvolts to somewhere around like 900 nanovolts. That's pretty amazing. That is in part why people pay big money for these audio analyzers. The next thing we'll do is let's turn on the high performance sine analyzer. That is the difference between the APX525 and the APX555. And that is where the money is, because that allows you to basically measure incredibly low distortion. Let's just turn the generator on and we have this. So I can change the generator amplitude. Let's say I want 1 volt, or if I want to go in steps, I can do that. Change the frequency, and so on. And over here on the measurement dashboard, we see various measurements for frequency, THD plus N, and so on. And I like to have it in dB. That's a little bit easier. And that's pretty amazing performance. If we then look at the FFT, we now have the option to change the FFT length. Let's just go with 65 or 64K and change the averaging to maybe 4. And let's let that rip. And this is why people pay money for these audio analyzers. Let's change the units to dB volts. So now the 0 dB volts, that's 1 volt. That's the top reference. And then you see the second harmonic right here is just above the minus 150 dBc line here. The third harmonic, at least in this measurement, you might be just be able to see it. I would have to change the FFT settings a little bit, then we can tease it out of the noise floor. This is why people pay big bucks for these audio analyzers. The other thing that we notice here is that the software is really intuitive to use. If I want to change something with the y-axis, there's this little arrow that shows up, and I click on that, and I can change the unit, I can set auto scale, properties, and in the properties I can change, let's say I want 20 dB for the maximum. Ta-da, done. And similar for the x-axis, of course, and then if we right-click on the graph, we get this context menu with all sorts of options and settings, and I can click Graph Properties. That just brings us to the same dialog, but with the General tab selected. I can type in the title of the graph, I can turn the legend on and off, and so on. It works like you would expect it to. So that is what makes this software such a joy to use. Most audio analyzer software appears to be set up sort of like a real-time analyzer, so they put the FFT, or fast Fourier transform, front and center in the software. What I end up doing the most, though, is sweeps. So either sweeping a generator frequency or a generator amplitude and looking at the performance of a circuit as function of those two variables. And that's what happens here in the sweep pane in the software. And as you can see here, the source here can be generator level, generator frequency, all sorts of other stuff. And you set the sweep endpoints, how many points you want, logarithmic, linear, or you can do a custom sweep. You can also run what they call nested sweeps. So that means you run one sweep of, say, generator level, and then the secondary source could be the generator frequency. So that's how I get the plots where you have one line for, say, 100 hertz, 1 kilohertz, and 6.6 kilohertz swept from some amplitude to some other amplitude. So now we're looking at THD plus N versus the generator amplitude. And we can see that we should probably change the y-axis here. So let's just do that. First, let's start by putting it in dB. And then let's set the endpoints. So I hit the properties. I can do that while the measurement is running, which is really nice. And let's say minus 60 at the top and minus 140 at the bottom. And now the graph is a little more useful. So I'll just let this finish. You can watch, well, we can watch it together. What I really like about this, you have a progress bar, and also you see the result update along the way. It gives people a little bit of hope that, you know, how far along are we here and when is this going to end? And it'll end pretty soon here. So one thing we notice is that the graph is a little jumpy here. And you might be able to hear the audio precision go click whenever there is a sharp transition like that. And these transitions happen because either the generator is changing its amplitude range, or the auto range on the input is saying input's too high and let's change the attenuator setting. So what we see here with the APX 555 is that we get a lot of these sweet spots. So those are good spots to operate the analyzer. For example, you'll notice that some audio companies, they specify the performance of their products at 5.5 volts, and that just happens to be a sweet spot on the APX 555. What you also get is with the 555 is you get a lot of input and output ranges. So that means that your measurements are mostly going to be looking at distortion and not so much at the noise of the measurement setup, which is dominating here. With the lower cost analyzers, you don't get as many ranges, and with a sound card, you don't get any range at all, aside from a gain adjustment that may or may not be all that useful. Another feature that I use a lot in the APX 500 software that I don't find in other softwares is the ability to regulate the generator amplitude until a measured parameter reaches some point. And that is really handy, for example, if I have an amplifier hooked up and I want to regulate its input voltage until it provides 1 watt into, let's say, 4 ohms. I do that by first making sure that in the references I have 4 ohms typed in here. So type in 4 ohms, and then under regulate, I select I want the RMS level to be the measured parameter. The target value should be 1 watt. And yep, I can actually just type in the unit right there. I told you it was intuitive. And then let's say set the boundaries for the generator. So let's say we want to go no lower than 0.1 volt in our search and no higher than 4 volts. And then I just click start and the software does its thing and it figures out that at this generator level, the output power of that amplifier is 1 watt. It really just does the V squared over R, where R is the reference resistance. But that is actually massively handy when testing power amplifiers. Another function that's really handy that I'm surprised I haven't seen in other softwares is the recorder. So that basically emulates one of the old strip chart recorders. So what we see here is time on the x-axis and the measured parameter on the y-axis. And if we start that, we can see that the generator provides the 2 volts, and if you turn it off, then voltage drops and so on, and we can turn it back on. In this scenario, I just ran it for 10 seconds, but I run it for like an hour for measuring thermal systems and stuff like that. You can also DC couple the input of the APX555 and the other APX analyzers, and that allows you to measure a DC voltage as a function of time, and that's actually pretty handy. I have almost only praise for this software. When I first bought my APX 525 10 years ago, I was told that AP had won quite a few prizes with this, and I can see why. It's lovely software, but it does have a couple of shortcomings. And one is related to the use of the cursors in the graphing tool. The graphing tool itself is fantastic. I mean, it's production level graphics, but the cursors, let's say I run this FFT and I want to know the amplitude of that third harmonic there. I click on the cursor, I drag the cursor over there, and I can't reach the peak because the FFT length is long enough that I basically can't hit the peak right on the head there. So I will zoom in and do that. And then I have to remember to unclick the zoom function before I move the cursor. And now I can get to the top of this peak here, and it rings in at minus 151.9 or minus 152 dBc. And if I then click back to zoom pan to original, like that, now we see that the marker has dropped off the peak. So that means I can't set the markers on the harmonics and get them listed in this little table here. And that's really unfortunate. And also, I mean, all the free software has an option to just click a button and then you get all the harmonics listed. And you even get the THD, not the THD plus N, but just the raw THD calculator from that. And that's missing in the AP software, and I think that's really unfortunate. You can measure raw THD with their continuous sweep, which is a way of using a log chirp, so a signal that goes, and then from that it measures gain, phase, and so on, but it also measures THD. But when you do that, you lose the ability to use the high performance sine analyzer. And that's really why you buy the APX 555. So I really wish that they would just add a button so that I could get the total harmonic distortion in an FFT. But that, I think, is basically my gripe with this software. And, that's pretty good. Alright, so enough about the audio precision stuff. Now let's talk about the QuantAsylum QA403, and that's what I have here. It is a pretty small device, and that also means that the connectors are packed pretty tightly here. It's all BNC connectors, and unfortunately they're not on any sort of standard spacing, and that means that you cannot use BNC to, say, banana plug adapters with this. That's a bit unfortunate. But QuantAsylum is actually not the first company to bring out balanced inputs and outputs on BNC connectors. HP did that on their 8903 distortion analyzer, which may be where these guys had the idea from. So for single-ended inputs and outputs, that's really not that big of a deal. You hook up to one of the BNC connectors and off you go. But for a balanced connection, you will have to come up with either a custom cable or a custom adapter, and I'll show you one in a little bit. But now let's plug this into the audio precision analyzer and take a look at the performance of the generator. Now let's take our first look at the software for the QA403. It seems pretty well organized. It has some sort of control panel here on the left, and it has a graph for the output on the right. So far, so good. I have the generator set up to provide 8 dB volts, or about 2.5 volts at 1 kilohertz. That happens to be one of the sweet spots on the QA403, and I will turn the generator on. And I do that by clicking the Gen 1 button. And it does indeed tell me that it is outputting 1 kilohertz at 8 dB volt. But I didn't hear any relays click in the APX555, so that seems a bit odd. So I look at it and yep, there is indeed no output. So what's going on? Well, it turns out that the QA403 doesn't actually provide an output on the generator until you select idle mode or until you select to run a test. So let's click idle. So now we should have an output, and we do. We get 2.51 volts, which corresponds to 8 dB volt, exactly as we programmed. Sweet. We also see that we get a THD plus N of about -111, which is quite good. That's excellent. And if we look at the FFT, we can see that it is primarily dominated by odd order harmonic distortion. That distortion plus the noise gives the -111 THD plus noise. Now let's look at the analyzer section of the QA403. As I mentioned earlier, the inputs here on the QA403 are balanced, so that means if you hook up a single-ended source, you will need to terminate the unused half of the input. And the easiest way to do that is to get one of these BNC 50 ohm terminators. I painted mine green to remind me that this is a 50 ohm and not a 0 ohm shorting plug. Those exist as well. These are pretty affordable. So you just terminate the unused half of the input like that, and then plug in the generator. Single-ended like that. I will turn the generator on. I have it set for 8 dB volts at 1 kilohertz. So let's pop into the software for the QA403. The first thing that we need to tend to here is the attenuator. So the full-scale input, we should select something that's about 6 to 12 dB above the input voltage. That is probably going to be either 12 or 18 dB volt. In fact, let's go with 18. If you read the manual for the QA403, you will notice that they recommend that you use a Hanning window for the FFT windowing. So it's a bit odd that they have chosen flat top as the default when you install the software. I mean, of course, the fix is easy. You just click Hanning window and then off you go. And to start the test, you simply click Run. So great. Now we should start getting some data. Fantastic. So the first thing that comes to mind is that we'll need to change the y-axis to capture the full magnitude of the fundamental. And I mean, I spent, I don't know how long double-clicking various components here of this graph. I mean, you can right-click, then you get a context menu that'll allow you to save the image. That's cool. But there is just no way to change the axis settings. Clicking the x-axis, same thing. And it wasn't until I floated over here and noticed that these are actually buttons. I mean, they look like they're just grayed out. So inactive fields of some sort, but I can click that. Okay, that does nothing. But what happens if I right click it? Oh, now we get the axis settings here. So let's do let's do +10 since we have +8 coming in. So now we have the full fundamental captured. Needless to say, I mean, the software is a bit kludgy and not super intuitive to use. It's not like I can't get anything done with it. It works, it does what I need it to do, but it takes some fighting to get there. But anyway, so now we have the measurement here, and we also have THD and THD plus N indicated, and that's pretty cool. And actually a THD of -120, that's kind of impressive. And if we want to look at, say, how tall is this magnitude here, we just click on it and we get a marker. And we can click on, say, the second harmonic and the third harmonic. it can be a little bit tricky to hit the exact point that you need to click, especially if you're running at 192 kilohertz sampling with a 90 kilohertz frequency axis. Then hitting the exact point can be a bit tricky, but this works, and this is actually I mean, the APX 500 software doesn't do this. So QA is ahead of AP already. So that's pretty cool. And the performance of the analyzer section is really quite good. It would be interesting to see what happens if I plug in a balanced source, however. Most audio equipment that has balanced output will have it on an XLR connector, just like the Audio Precision does. But that needs to get into these BNC connectors. And to do that, I have come up with this adapter here, where I sacrificed a couple of Pomona test leads and an XLR connector. So that gets me from XLR to banana plugs. You can convert from banana plugs to BNC pretty easily. You can get adapters that take the center conductor and bring that out on a banana plug, and I will pop that into the cold input, or the minus input. And then for the in plus, I have this BNC to dual banana plug. So I will use that. And that gets me in plus, ground, and in minus. And in case you're wondering, the purpose of test equipment is actually not to help you test anything. No. The purpose of test equipment is to create a market for all these adapters and doodads that you need to use. So, whatever. After a while, you'll end up with an entire box of them like I have. So anyway, rant over. So now let's plug this in. So I start with in minus, and then in plus, and then ground. Let me see if I can get that wrangled in there. Like that. Okay, cool. So now we're going. And I have the generator set for 8 dB volt output and balanced out. And let's just click run. So now we should be getting some data. And what I immediately notice is that the harmonic structure has changed a little bit. Now the second harmonic is actually quite a bit down, whereas the third harmonic seems to be roughly where it was before. So that's kind of interesting. What I also notice is that the THD is about 3 dB better with the balanced input, so that's cool. But unfortunately, what I also notice is that the 60 Hz mains component here is starting to pop up above the noise floor. I bet that is because of the added loop area of this adapter contraption right here. And I mean, there's no real issue with it. It just is. It's just one of those things that shows up in the plot, and I wish it wasn't there. But it's not going to impact your measurements any. But if it bothers you, I suggest that you make a custom cable that has an XLR connector on one end and 2 BNCs on the other, and just make sure that you keep the loop area where the BNCs branch out as small as possible, and you'll probably be fine. Let's have a look at how the QA403 performs when connected to itself. So I have the generator output connected to the analyzer input with the coax cable, and I have the unused half of the input connected to a 50 ohm terminator. So this is a single-ended connection, and I have run an FFT. As you can see, we get these mains components showing up. And that's a bit unfortunate because, I mean, it's a blemish on an otherwise really good piece of hardware. I'm not going to cry myself to sleep over it, especially considering that the hardware is only $600, but I kind of wish it wasn't there. And it goes away when you're using balanced connections, so it has to do with probably the input circuitry of the analyzer itself. Anyway, what I do want to demonstrate here is the automated test that you can run with the QA403. Specifically, I would like to look at how does the THD plus N behave as function of generator output voltage. And that can be run in one of these automated tests here. I click here and then I select THD versus input output level. So now I get this dialog box. By default, it is running at the settings that you have configured the program for. But if you want a little bit more repeatability in your measurements, I suggest that you save the settings in a file. Then you can input the file here, and you always run the THD plus N sweep at the same settings. And let's go from like -20 to +18 dB volt. +18 is the maximum in 2 dB steps. This will take a while. Of course, you could just make the step size larger, but there is a little catch there. For example, if I set the step size to 5, that doesn't divide evenly into the 38 dB span, so the last step is skipped. That's just one of those, could that be better? I would rather just let's define some number of steps, 31 steps, and then you click go and it automatically figures out, where the steps should be. But anyway, let's let this one rip. So it automatically sets the attenuator for you based on the parameter that you set in that dialog box. That's pretty cool. It's basically kind of a poor man's auto ranging. The box actually doesn't support auto ranging, which is a little bit odd, but that would be a feature that's pretty easy to add, I would think. Another feature I would like to see is it just says testing in progress. That's great. How far along is this test? I mean, you can get a guess from the generator level that it has reached here. But it would be nice with either a progress bar or just sort of a completing step 20 out of 31 or something like that in this dialog box here. So, and there's room for improvement in the software. But I'll let this finish, and then I'll come back when I have results to show. Oop, almost there. Last step. And here we go. So we can see the effects of I think it's a digital attenuator that runs here. And then at this point, the analog attenuator, the hardware attenuator in the QA403 kicks in, and that's why you get this jump in THD plus N. That's just the plus N, or the noise, that increases at that point. You can't have attenuation without noise, unfortunately, such as physics. That's pretty cool, and I actually kind of like this editor. It's a little bit sort of crude, but it really does work. I can type in a title, I can change the axes, and do all sorts of things. And one thing I really appreciate is actually that the THD plus N is indicated both in dB and also in percent. It would be nice if it said 10 and 100 instead of the scientific notation, but it works well enough, and it spits out a pretty nice PNG graphics file. I mean, that works. It's a little unfortunate that it is so slow. I mean, I have chosen some settings here that makes the test go pretty quick. If you want a bit more resolution in the measurement, then use different settings. Use a longer FFT, for example. But unfortunately, that means that the test takes longer because it relies on the FFT for these measurements. When I was taking the measurements that you see on my website, I was running sweeps that took about 10 minutes, and on the APX 555, the same sweep would have taken about 40 seconds. So it's not a fast device, but it does work. And unlike the AP, it allows you to do a THD without the plus N versus input or output amplitude. So that's cool. One word of warning with sweeps in this software, especially if you sweep the generator amplitude, is that the generator settings that exist after the sweep correspond to the last point in the sweep. And that means that, let's say you have the software set up for 1 volt output, you run the sweep up to 2 volt output, and then you come back and then you, out of habit, turn the generator on. It's going to be set to 2 volts output. And if you run a sweep where you run, say, a power amplifier from a fraction of a watt well into clipping, you could be in for a bit of a nasty surprise. So that's just something to keep in mind. And also, as I promised, I have high standards and low patience when it comes to software. So let's talk a little bit more about the QA403 software. One thing that I really wish they had done differently is this control panel here. I mean, in one sense, it gives a good overview of what your options are. But on the other hand, it paints the design paradigm into a corner where everything has to be represented with this sort of button that would exist on a physical instrument. And that doesn't really work so well for software, in my opinion. For example, with the axis settings, I mean, how would you integrate that into this? And the fact that you don't have a properties setting or a properties option here is sort of that's really unfortunate. The other thing that I notice is that we have these measurements here, for example. Okay, so I can click on gain, and now a gain option shows up, but the corresponding button doesn't light up here. Shouldn't this be lit if gain is selected? And if I click on it again, gain goes away. And it's just, come on guys, I mean, let's be a little consistent here. And it gets even worse when we look at how to set the axis settings. I mean, I covered it a bit with the y-axis that you set with these elements that appear to be inactive, and you right click on one and you get the axis settings. Okay, fine. But where is the setting for the x-axis? I mean, how do I even do that? I have to right click on this button where I select between linear and logarithmic, and that gives me this dialog where I can then enter the frequency axis endpoints. That's just not intuitive. And it took me a long time to figure out, you know, how do I even do this? And I shouldn't have to fight like this. That's just it. I think it's really unfortunate. But I mean, interestingly, I mean, maybe this is just a rite of passage for audio analyzer companies that they have to go through this phase where the hardware is pretty amazing, especially for the price, but the software, well, quite frankly, sucks. AP went through something like that where the software for the generation of analyzers that came before the APX 500 series, it was really difficult to work with, I found. And it's one of those where, or at least unintuitive to work with, and it's one of those things where, yes, I could get the job done, but man, was it ever a fight to get there, and especially the first time around. And that's the feeling I get left with here. And it's a bit of a shame. I mean, fortunately, software is easy to change, whereas hardware is a lot more expensive to change. And the hardware is good. It would be nice if they could get that ground hum figured out. But aside from that, you know, I really can't find any flaws with the hardware. And I think you get a tremendous bang for your buck, especially for the $600. So fantastic. The software, that could use some improvement. That said, if you have your own software that can use an ASIO driver, then there is actually a community effort to create an ASIO driver for the QA403, and that's called ASIO 401. It's on GitHub. I haven't tried it, but that would be worth a try. And then you can use software like Rev or Arda or even the APX 500 software. So that might be an option for you. To be able to have an informed opinion on the QA403's performance, I took many measurements that I haven't shown in this video. If you're curious about those measurements and would like to see the performance of the QA403 in more detail, I suggest you hop on my website, and that would be neurochrome.com, and in the resources section under technical articles, you will find an article titled Measuring Distortion on the Cheap. And in that article, I go through first the performance of the APX 555 for reference, and then the QA403, and then the sound cards that we'll look at next. The first sound card I will look at is the Focusrite Scarlett 2i2 4th generation, and that's what I have here. I have connected its line level output to its line level input. I have adjusted the volume control for the output to the maximum. That's generally where you find the best performance for the deck. And also I have adjusted the input gain for the best THD plus noise. I then adjusted the output amplitude to further reach the sweet spot as far as THD plus noise goes for this particular sound card. And speaking of sweet spots, with the QA403 you had multiple sweet spots, or definitely one major one, where the analog attenuator kicked in. With the APX 555, the 525, you get multiple sweet spots. But with the sound cards, you basically get one sweet spot. So if you don't provide that voltage, then it's not going to perform as well. And that's the trade-off you make in exchange for the lower price. But let's see how it performs. As you can see here, I am using the APX500 software, and I have the output configured to use the Focusrite ASIO driver, and I have the input configured to also use the Focusrite ASIO driver. So that allows me to use software that I'm familiar with to test this sound card. That's pretty handy. I love these ASIO drivers. If the sound card you have doesn't have one, there's a driver called ASIO for All that will probably help you out. Anyway, let's take a look at the performance here. The best performance I'm able to squeeze out of this sound card is a THD plus N of about minus 100.5-ish. And that's not exactly stellar, especially not compared to the QA403, but for a consumer level sound card at the $200 level, that it meets my expectations. Let's look at the FFT. So this is the frequency spectrum of the sound card in loopback mode. And as we can see, the THD is basically dominated by this, what is that, the third harmonic of the fundamental signal here. And I mean, this is not too bad. Minus 105 is sort of, I mean, a consumer level DAC I would expect to get down maybe around minus 108, and this is 3 dB off. Yeah, okay, it meets my expectations. So the performance is pretty good when I used balanced in and balanced out. When I used single-ended in, the performance degrades. And I can demonstrate that by building a Christmas tree of adapters here. So I have an XLR to RCA, RCA to XLR. I told you it was all about the adapters. And then to make it even more fun, let's do XLR to TRS. So now we have balanced in, unbalanced in the middle, so that turns this whole thing into unbalanced. That means that the tip is hot, the sleeve is grounded, and the tip is hot, the ring is grounded, and the sleeve is also grounded. And now let's plug this in. Alright, so like that. And now let's have a look at the THD plus N. And this is horrible. I mean, minus 66, that's not even consumer grade. So it turns out that you can actually reach a sweet spot. The sweet spot with balanced in, balanced out is at about 1.6 volts and an input gain of 10 dB. Interestingly, with single-ended connection, the sweet spot is at 160 millivolts and an input gain of 30 dB. And that seems really odd. And the performance is still not great. You see minus 81 dB for the THD plus noise, and that's really unfortunate. And let's just run an FFT and see where that degradation might come from. Even though the measurement isn't quite finished here, it's pretty clear that the degradation in THD comes entirely from harmonic distortion. The noise floor does degrade a little bit, the mains hum creeps up a little bit, but the degradation in distortion is what drives this. And that's unfortunate because most audio circuits, at least at the consumer level, have RCA outputs which are single-ended. And with this kind of performance, that basically means you cannot use this sound card to measure the performance of your audio circuits if they have single-ended inputs or outputs. That is unfortunate. I should also point out that the firmware in this sound card appears to be a little bit buggy. And that is in spite of the fact that I updated it to the latest version before I started my testing. And the bugs come across when I plug it in, where it doesn't always register properly. It registers to the point where I can change the sample rate, the inputs work, but the output does not, and none of the LEDs or indicators on the front light up. So I'm not really sure what to make of that. It seems to be a little bit half-baked at this point, and that bugginess presents itself both on the PC that I use with my APX500 software and also on my Mac, which I use for my everyday tasks. So I don't know. I don't think there's any reason to spend more time of this video on this sound card. Our final test subject here is the Focusrite Scarlett Solo. This is the third generation of this particular device, so it's a couple of years old. They sell refurbished from Focusrite for $80 right now, and I would argue that is incredible value. But let's see how well it performs. So finding the sweet spot on this is actually really easy. For the DAC side of things, you just crank the volume control to the maximum. Done. For the input side, all you really have to do is to adjust the input so that it's just below clipping. And that's really easy to do thanks to this VU meter indicator. And you basically, so when the level is 24 dB or so below clipping, it turns green. And then as you increase the level, it turns yellow once you're approaching clipping, and once you're into hard clipping, it turns red. So with hard clipping, you get massive amounts of distortion, of course. So you just turn it back down until it just turns yellow, like that. Ta-da! And if we pop into the AP software, we notice that the output of the DAC, or the output of the ADC rather, is at just below clipping. So clipping would be 0 dB FS, so 0 dB full scale, and we are 0.2 dB below clipping. And we get about 95 dB THD plus noise. Compared to the other devices I've looked at so far, that's not fantastic, but I mean, that's like $1 per dB. Or maybe even a little bit better than that. So, you know, this is really not bad. I've been recommending this for a few years now, and I think I stand behind that, at least from the results I've seen until now. But let's dive into the FFT. And there you have it. Basically, the harmonic distortion, or the THD plus N, is dominated by this second harmonic, which clocks in at somewhere like, it looks like minus 98 point something dBc. And, you know, I mean, for an $80 device, that's really not bad. So yeah, I would go with that. But let's try the adapter trick to see how this performs with a single-ended input. So I will just unplug here and then add my little Christmas tree of adapters. And now we have a single-ended signal here, and I plug that in, and I'll adjust the level until it is just below clipping. So dial it up to red and then dial it back till it just turns yellow. And let's see. So now we're looking at about minus 93 dB THD plus N. And yes, that does represent a 2.5 dB degradation. And, you know, I mean, that just is what it is. Let's hop into the FFT and take a look at the frequency spectrum. So the distortion is dominated entirely by this second harmonic, which clocks in at around minus 96 dBc. And there's some other harmonics in that, along with the noise, add up to the minus 93 dB THD plus N. We also see a little bit of mains hum, although at a very low level, starting to creep in with the single-ended connection. That's not a surprise, it just is. So in my opinion, you get, you know, really a quality device for $80. It's not going to be as high performant as the QA403, but it's also like less than 1/6 the price. And that's, I mean, that's pretty amazing. You will be able to characterize quite a few circuits with this, including vacuum tube based circuits and most power amps, except for the ultra low distortion ones. I'm willing to accept that in exchange for the low price. At least the performance doesn't go completely to crap like it did with the 2i2 Gen 4. It does have an instrument mode. So let's try and play with that a little bit. I have to turn the gain down, so there we go. Let's see here if we can do better. Yeah, so with the instrument mode, it looks like the best THD plus N I can get, at least with this amplitude, is about minus 80 dB. And that's not fantastic. So I kind of wonder if the 2i2 Gen 4 has a sort of smart input that automatically senses when you plug in an instrument like an electric guitar or something like that, and it changes it to the instrument setting without lighting up the indicator on the front panel.
I don't know. I mean, it's my guess. I just can't explain why the 2i2 would be such a poor performer with single-ended input when the Gen 3 works just fine. If you're interested in more measurements of this sound card, please jump on my website, because in the resources section under technical articles, you will find an article that's titled Distortion Measurement on the Cheap. And in that article, I have a whole bunch of measurements of this device that you can check out. The software that comes with your sound card is usually not useful for audio analysis, but thankfully there are some free options out there. And one such option is ARTA, ARTA, which recently became freeware. I'll drop a link to it in the description below. And also Rev, a room equalization wizard, seems to be very popular, and that's what I show here. Let's turn on the generator here. So click generator, and I've set the amplitude, and we click go. And it's a little bit counterintuitive that when you start the generator, then the waveform disappears from the display here, but such is life. What I do like about it is that you can click calibrate level, and then you can just measure the output with a voltmeter, and then you get to type in your voltages directly, and you get a calibrated output. That's pretty cool. So let's look at the spectrum analysis, and that happens up here in RTA. And let's get that running. So now we are going here, and we see that the harmonics are indicated with their numbers here, and we also see that the THD and THD plus N are listed right up here, and that's pretty cool. I mean, that's pretty neat. We can also see the input voltage right here and the settings for the FFT here, and if you don't like seeing all this stuff, you can just click them off. So that works pretty well. I generally find Rev pretty intuitive to use. I mean, if you want to click or change the axis setting, you just double click once this blue thing shows up. You get to change the settings, and you can auto fit and so on. And similarly with the x-axis, you can double click that and change that to your heart's content. So, I mean, that's pretty cool. I do believe there is a way to get the graphics out of here. Yeah, you can click this camera icon, and then you can save the graph as an image. So that's pretty neat. And this table is exactly what I wish that the AP software would have. Just give me a button to click so I can get that table, because that is actually super useful. I believe it also does sweeps, and I mean, you can check out the generator here with multitone and noise and sweeps and all sorts of stuff. This is a real McCoy. I mean, it is a fully fledged piece of software. The programmer of it, or the developer, does ask that if you end up using it, that you give them a donation, and that seems pretty fair. One thing I would like to point out, though, is that both with this and with ARTA, and likely other softwares as well, you need to go in and make sure that dithering either is turned off or is turned to a fairly high value. By default, it comes with 16-bit dithering turned on, and let's just see what that does with the graph here. So, whoops, I ended up turning it off. See, I think it would be more intuitive if this changed to a red square for a stop when you click. So, but anyway, let's get this going again. So now you see the noise level is quite a bit higher, and the THD plus noise is quite a bit higher as well. And that's simply because of dithering. If we turn dithering to 24 bits, now the noise drops. So if you're having issues reaching a good THD plus noise with your sound card, make sure that you have dithering either turned off or turned to like 20 bits or beyond. So both ARTA and Rev are available as free downloads, so, you know, download both and play with them. So that's really all there is to it.
So there you have it. I was really impressed by the performance of the QA403. It is a solid piece of hardware. It's a little annoying with the B and C's for balanced inputs and outputs, but you can get over that. And also, the software is a bit quirky. But honestly, once I got the hang of it, I could figure out how to do the things I needed to do pretty easily. So I would certainly recommend it if an APX 555 or any of the other AP products is not in your budget. For the sound cards, both of them actually provide really good value for the money, but they also don't cost a whole lot. I was not so impressed with the 2i2 when it came to single-ended input. I mean, it's basically useless for that, and that means that it's not very useful for audio measurements. It performed really well with a balanced input though. For the third generation Solo, that would probably be my choice if I was going for a low-budget solution, because at the current price point, it provides pretty amazing performance, both balanced and unbalanced. And I would imagine that the third generation 2i2 has the same input circuits. So I would imagine, I would guess that it performs just like the third generation Solo. So that's it. Thank you very much for watching. I really appreciate it. And drop me a like, drop me a comment. I do read the comments. It might take me a little bit to respond, but I do read them and I thank you for those. So thank you very much and have a great day.